Okay, for topic 4, we're going to talk about using the fundamental identities. So I already told you that we have this like kind of packet of identities called the fundamental identities of trigonometry. So that's the reciprocal identities, the quotient identities, and the Pythagorean identities. So in some cases, we'll need to use them because by understanding these identities, we can simplify things very beautifully. Okay, so for example 5, it says, without using a calculator, find the exact value of each expression. Okay, so first we have 1 over cosecant squared of 35 degrees plus cosine squared of 35 degrees. Well, geez, there's a lot going on here. So I love when I see a cosine squared to have a sine squared along with it. That's very cool because if I have sine squared plus cosine squared, we know that equals 1. So I also remember we have these reciprocal identities, and we know there's a relationship between sine and cosecant. And so the relationship is that cosecant. Actually, let me do this inside the problem so I don't run out of space. So the relationship is we know that cosecant theta is equal to 1 over sine theta. Well, that goes without, well, I want to say it goes without saying, I'm going to say it anyway, that means that sine of theta is equal to 1 over cosine, or not 1 over cosine, bless my heart, 1 over cosecant. Good Lord. That would have been a disaster. 1 over cosecant theta. Well, we have a relationship like that. We have 1 over cosecant squared of 35 degrees. So we could basically replace this right here with sine. Okay? So we can say 1 over cosecant squared of 35 degrees is really the same thing as sine squared of 35 degrees. And then I already had plus cosine squared of 35 degrees. Let me kind of separate these two sides, okay? And now what we know is if we have cosine squared theta and sine squared theta, the relationship between those is one of the Pythagorean identities. Sine squared theta plus cosine squared theta, whatever theta is, you can replace theta with any angle in degrees or radians. Sine squared of theta plus cosine squared of that same theta has to equal 1. So there we've used one of the fundamental identities. Okay, now for part B, we have cosine of pi over 3 divided by sine of pi over 3 minus cotangent pi over 3. Again, a lot going on. But anytime we see sine and cosine written as a ratio, we should start thinking quotient identities. So what we need to remember is that tangent of theta is equal to sine of theta divided by cosine theta. And we already know that tangent and cotangent have this reciprocal relationship. So cotangent of theta is equal to cosine theta over sine theta. Well, that's really, really helpful in this example. So if I look right here, I have cosine of some angle divided by sine of that same angle. That relationship is cotangent. So I can say that this is cotangent of pi over 3 minus cotangent of pi over 3. Well, we would have a ratio minus the exact same ratio if we were going to figure out what cotangent of pi over 3 was. So this would just equal 0. So there you have it. So you've used, in this case, you've used reciprocal identities and quotient identities. Okay? Now let's look at example 6. Example 6 is going to require a bit more work. Okay, so example 6 says, given that sine of theta equals 2 over 5 and theta is an acute angle, find the following. Well, a lot of times when they give you information like that, what they don't necessarily tell you is if you can draw the triangle, you can get a lot of information from it. So that's what we're going to do. So part A here says, find the exact value of each of the remaining 6, or well, there's 5 remaining, but find the rest of the 6 trigonometric functions. Okay, so let's just go ahead and draw this. So we have a right triangle, okay? And let's label theta as right here. We know the relationship between theta and the sides of the triangle as far as sine is concerned is always opposite over hypotenuse. So 2 is going to represent the length of the opposite side compared to theta. And then 5 is going to be the hypotenuse. And if we use the Pythagorean theorem, we can figure out what the adjacent side has to be. So the Pythagorean theorem says a squared plus b squared is c squared. Well, we don't know what a squared is, but we know that b is 2, so 2 squared. We also know what c is, it's 5 squared. So let's see, that gives me a squared plus 4 equals 25. So I want to get a squared alone. So that tells me if I just subtract 4 from both sides, I get that a squared is equal to 21. And then I would need to take the square root of both sides. And so that tells me that a is plus or minus the square root of 21. We're going to say in this case, it's just going to be plus. So we're going to say square root 21. So it's not necessarily the prettiest value we've ever seen, but we can work with this, okay? So we already know that sine of theta is 2/5. We were given that. Well, cosine of theta, we know the relationship between theta and the sides of a triangle as far as cosine is concerned would be adjacent over hypotenuse. Remember, so TOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So if we look at the adjacent side compared to theta, we get square root 21 and the hypotenuse is 5. That's it. So then tangent, we know the relationship between theta and the sides of the triangle as far as tangent is concerned is opposite over adjacent. Well, the opposite side is 2. The adjacent is square root of 21, so we do need to rationalize that. And I already told you, you really need to get into the habit of rationalizing. If it's not something you're comfortable with, you need to practice it, okay? Because it's going to come up a lot. And it needs to be one of those things that you can just do, okay? So to rationalize this, we multiply by the square root of 21. Well, that gives me 2 square root 21 over, well, the square root of 21 times itself is just 21. So we get 2 square root 21 over 21. Okay. Now, if you can get those three, you can use the reciprocal relationship to easily find cosecant, secant, and cotangent. So cosecant theta is the reciprocal of sine, so that would just be 5 over 2. Secant theta is the reciprocal of cosine, which would be 5 over root 21. So we do need to rationalize this. So we multiply top and bottom by the square root of 21. I hope you can see that when we have the square root of 21 over itself, it's just 1. So we're not changing the value of what we're starting with. We're just kind of taking that radical out of the denominator. Okay? So let's see, we get 5 square root 21 for the numerator. And then the denominator, if you take a square root and multiply it by itself, you just get the radicand. So the denominator here is just 21. So let's make sure we get these circled or boxed in so you can see them. And then finally, we have cotangent of theta. Well, cotangent is, you can do this two ways. So you can do just the reciprocal of tangent, or you can remember up here that if tangent is opposite over adjacent, cotangent is going to be adjacent over, whoops, I have that written funny. So you can use the reciprocal of this relationship. It'll be a little bit easier than using the reciprocal of what we have here. So cotan of theta is equal to the reciprocal of tangent. So tangent is opposite over adjacent. So cotangent is adjacent over opposite. So that's going to be a little bit easier than finding the reciprocal of this. So we want adjacent, which is square root of 21, over opposite, which is 2. Now, if you were to use the reciprocal of 2 square root 21 over 21, you'd have to rationalize it again. Or you could just use the reciprocal of this one. Okay, so there's a few different ways that you can figure cotangent out here. Okay, so we found the 6 basic trigonometric functions. We already had cosine, or we already had sine, so we found the other 5. Now part B is a little bit different. Part B says find the exact values of cosine and cotangent using identities. Okay, so let's think about this. We have a few different identities that involve cosine and cotangent, but let's go to the Pythagorean identities. So we know that as far as cosine is concerned, if I have sine squared of theta plus cosine squared of theta, that has to equal 1. I'm just going to kind of split my screen in half. Okay, so what was sine of theta? Well, sine of theta was 2/5. Okay, so we can take 2/5 and square it. And then we can kind of solve for cosine here. Okay, so let's see, 2/5 squared. I would square the numerator and the denominator, so that would make this 4/25 plus cosine squared theta equals 1. I want to get cosine squared theta alone. So the issue is this 4/25. I need to subtract it from both sides. So when I do that, I'm left with cosine squared theta equals 1 minus 4/25. Okay, so let's think about this. We need to understand basic stuff with fractions. So when you're subtracting numbers involving fractions, you need a common denominator. So is there a way that I could write 1 where I have a common denominator and I can subtract? Well, yes, there is. So we get cosine squared theta equals 1. Well, I could write 1 as 25 over 25. Then when I subtract 4/25, I have a common denominator, and this is really easy to solve. So when I do that, I get cosine squared theta equals 21 over 25. Well, it told me to figure out what cosine is. I have cosine squared at this point. So let's take the square root of both sides. So when I take the square root of both sides, I get cosine theta equals the square root of 21 over the square root of 25, which is just 5. And if we go back over here where we use just the right triangle, we got square root 21 over 5. So this is another way that you could technically use those identities. Okay, now let's do the same thing with cotangent. So you may not remember this from the previous video, but we do have a relationship involving cotangent. So 1 plus cotan squared theta is equal to cosecant squared theta. Well, darn, that's a lot, but we do know that cosecant is the reciprocal of sine, right? So if sine is 2/5, that tells me cosecant has to be 5 over 2. So let's use that. So we have 1 plus cotangent squared theta equals, well, cosecant, again, is the reciprocal of sine, so we want to take the relationship that we had for sine, which was 2 over 5, and find the reciprocal of it, and then square it. So let's see, we've got 1 plus cotan squared theta equals 25/4. Okay, now I want to get cotangent alone. So the issue is the 1. So if I want to get cotangent alone, I need to subtract 1 from both sides. So that gives me cotangent squared theta equals 25/4 minus 1. Well, just like when we were looking for cosine, let's see if we can play around with that 1 to create a situation where we have common denominators. So cotangent squared theta equals 25 over 4. Is there a way to rewrite 1 where we have 4 as the denominator? And the answer is absolutely. We would write it as 4/4. So that tells me that cotangent squared theta is equal to 21/4. Now again, I've got cotangent squared, but I want cotangent. So if I just take the square root of both sides, I get that cotangent of theta is equal to the square root of 21 over the square root of 4, which is just 2. And where did we have that one? Right here. So you can see, again, it matches. So whichever one works for you, you can use identities, you can use the right triangle trigonometry. Either way, you get the same answer. Okay, so that's it for this video. I think in the next video, we're going to start talking about complementary angles and cofunctions.